We want to find the integral of secant theta times secant theta plus 3 tangent theta. Well, this obviously is not something that we readily know the derivative of. So what we're going to do is we're going to, and when I mean that we don't know the derivative of, we don't know a function whose derivative is readily this inside piece right here. Since we don't know that, we'll just try to manipulate the inside with equivalent expressions, and then once we have that reduced to something that is familiar to us, we'll go ahead and do the anti-differentiation. So what I'm going to do is I'm going to multiply secant in. We'll try that. Okay. So if we integrate, we'll have secant squared theta, because it'll be secant times secant, plus 3 times the secant of theta times the tangent of theta. And this d theta out here still remains effective to all of this. Now, we can use our integration technique for antiderivatives, and we can say that we can split these up because there's addition in between. And so we'll rewrite this as the integral of secant squared theta. Now this d theta applies to this guy, plus the integral. Now this 3 I'm going to pull out front, okay, because we can do that. Again, that's one of our rules for anti-differentiation. And this will be secant of theta times the tangent of theta d theta. Now what we'll do is we'll take a look at these inside pieces right here and right here, and we'll look at our differentiation, and we'll say, do we know a function whose derivative is either of these guys? So the function f is a function of theta whose derivative is secant squared is the tangent. So if we let the original function be tangent theta, we'll put a little constant at the end there, and if we differentiate this, then f prime of theta is equal to secant squared theta plus 0, because the derivative, the rate of change of a constant with respect to theta is 0. So we won't even write that guy in there. But notice now, this guy right here has a derivative of our integrand. So then this is an antiderivative of this. And so this whole thing is equal to f, which is equal to tangent theta plus c. And I'm going to call this c1 because I'm going to have a different constant over here. Okay, just so I can differentiate between the two of them. So this guy over here, I'm going to erase this now. This guy becomes the tangent of theta plus some constants, so that we have the entire family of anti-differentiation, or antiderivatives, I should say. Okay. And now here, we're looking for something whose derivative is secant times tangent, and we know that that is the derivative of secant, but it's 3 times that value. So let's put our little plus in between. So we need 3 times the antiderivative of this is secant of theta plus a constant of integration. Now you might say, well, the 3's got to multiply by the constant. You're correct, it does. But 3 times a constant is still some constant. So there's no issue there. What I mean is, had I put parentheses around this, then 3 times this constant, as I multiply it in, it's just 3 times some constant, which is still just another constant. Now, if you want to call it constant 3 or whatever you want to call it, you can. But we don't need that there because I've already distributed it into both. So this is including the 3 being distributed in. Now what I'm going to do is I'm going to put all this together, but I have a constant here and a constant here. So what we're going to do is we're just going to say, let's let some arbitrary constant be equal to C1 plus C2. It's irrelevant. It's still a constant. So in the end, we end up with the tangent of theta plus 3 times the secant of theta plus a constant. And if we differentiate this, so this is our big F, and if we take f prime, if we differentiate this, the derivative of tangent is secant squared. The derivative of secant is secant times tangent. So this will be 3 secant theta times tangent theta. And of course, the derivative of the constant is 0. And if we factor out the secant, we're left with secant theta plus 3 tangent theta. And this guy right here is, if we go back to the original problem, it is the integrand. And so since this guy matches with this guy, we must have found the right antiderivative. So our check works. We can always check. Okay. And our final answer is this guy right here.